There we go. We're starting to wake up a little bit here. So my name is Stephen Fluin, and I am a developer advocate on the Angular team at Google. So my job normally has two parts. First, I help enterprises be successful with Angular. And second, I try to understand what it's like developing in the real world, in real-world conditions where life is not always the kind of perfect dream that the Angular team might want it to be for all of you developers. One of the things that we're trying to do over the next few months is really to encourage a larger enterprise community. And so if you are working at a company with tens or hundreds or thousands of developers using Angular, please reach out to me after this talk or online via Twitter, because I would love to talk to you about how we can connect different companies that are working with Angular so they can be better at doing what they do every day, share best practices, share the challenges and the solutions that we're all kind of finding together. So the goal of this talk, What's Up with the Web, is to really reflect on some of the macro trends that are happening across the world of web development. So many of us are keeping up to date with everything that happens in the JavaScript ecosystem. Every new framework that comes out, every new library, every new tool that comes out, every time every weird random project on the internet forks and splits into multiple different projects. This happens every day across the ecosystem. But there's some bigger trends that I want to make sure that we're remarking on and noting because they're important in terms of how they affect our lives as developers. So I'm going to go through this in 4 parts. First, we're going to reflect a little bit on how web development has changed for us as developers. Then I want to reflect a little bit on why this has happened. Then I'll give you a couple assumptions that you can make or shortcuts that you can take in order to short-circuit some of this decision-making and some of the weirdness that's coming from the web. And then we'll end up talking a little bit about how Angular is trying to forge a path to this new future, this new world of web development for all of you developers. So I do want to start by reflecting on what a wonderful, or maybe crazy is a better term, world that we live in today. So I found this chart on Wikipedia, and I really liked it. This is a very traditional web development chart, right? We've got on the right side there, you've got the server. That's where I do all of my coding, right? That's where my application is being run in my control, in my environment, and then we ship down these fully rendered pages to the clients. So that's kind of the traditional model for web development. But we've started throwing a lot of kind of monkey wrenches into that normal process, right? Things have started changing. Now, instead of writing code, we're writing code that writes code, or we're writing code that compiles and ships in 2 different places or is run in 2 different places. And so we're losing control of that single server-based environment that a lot of us are used to. I know for a long time this was my development model. I have the environment, I have all of the control and all the power, and then I ship down users HTML. But this has kind of changed, right? It started back in kind of 2008, 2009 with jQuery, AngularJS, this rise of kind of the new sort of way of developing web applications. But a lot of people are still building standard server-based applications today, and they're just starting to dabble into JavaScript. And they're starting to dabble into what does it mean to shift more and more of my application development over into the JavaScript ecosystem. And to note on that, there's a fantastic chart on GitHub by a gentleman, Kamran Ahmed. I don't know how to pronounce that name. I apologize if anyone knows him. But he created this really great chart of what it means to be a web developer in 2017. And so he starts off with this decision between, do I want to be a front-end web developer, do I want to be a back-end web developer, or do I want to focus on DevOps? And then as you go into each of these different categories, it blows out even further into all of the little decisions that we have to make now, right? We've got HTML, CSS, JavaScript, right? These are the standards that most of us already know. But then you've got things like ES6, CSS compilation, CSS frameworks. This is a world that continues to grow and grow in terms of complexity. Let's even take JavaScript, right? This JavaScript that we know and love. It's been around since it was hacked out in a weekend. It's a fever dream from the Netscape team, right? But it's not JavaScript anymore. It's ECMAScript, right? Even the names of the things that we're kind of used to have changed somewhat. And so for those of you who don't know, ECMAScript is really just the standard language specification that is the thing that is behind all of the JavaScript that we know and love. But it's even expanding beyond that because we have things like Typescript, which make this situation in a lot of ways better because it's pushing the frontiers in terms of the ways that we can be expressive in our applications and build applications that are maintainable and that scale really seamlessly. I'm going to stand closer to my laptop so my clicker works. When developers look at this small Angular component, a lot of them say, wait, what is that? That doesn't look like anything I'm familiar with. But if we understand and we break down the pieces, it's not actually that crazy. So at the top, we have a new syntax called a decorator. So you're going to see @component. This was something that the TypeScript team added in collaboration a little bit with our team. It was a standard specification that was part of the ECMAScript standard, or a proposed standard. Then we have more standard ES 2015 features, like exporting a class. Then you can see Angular is using dependency injection on our constructor. And then we have these lifecycle events that we're giving to you, all as part of a standard class in this JavaScript world. As developers, we used to build applications on the server, right? So every time a user requested a URL, there'd be a single lifecycle event. My application would start up. We would go fetch some state from the database, figure out what we needed to do, render that out to this a string, and then ship that down to the user. But then we shifted more and more of our functionality into single-page applications so that we could build experiences closer and closer to the eyeballs of our users. But what ended up happening was we kind of left some of the things behind that we had as server-side developers. And so now, in several places, and I'll talk about this a little bit further, we're building applications on the server again. We're building client-side applications that are being run and executed on the server. And this just, it feels a little bit crazy, right? We're reinventing the wheel, maybe. We used to have HTML, right? I used to generate an entire page of HTML, ship that down to the browser. I would know exactly how it would render. But if you look at the HTML that we're shipping as part of modern applications, it's very, very minimal. Here's a sample application from a real site that's 2 lines of code, right? All of the code for the website, the HTML code, fits on a single page. There's no syntax here. There's no layout. There's no information about what's going on, because most of the code has now shifted into the JavaScript world, into the JavaScript ecosystem, so that I get a full application mentality. Compiling is another concept that is kind of back in a lot of ways. So we started off writing HTML. So we had this nice markup language that we would know how it would render on the browser. But then we wanted richer, more engaging experiences. So we started writing programs that would listen for post events and get events and have web forms. And so we would be generating all of that HTML on the fly based on what we knew about the user in the current state. Then we started writing programs that would both generate information based on the current state, but we'd also start writing dynamic JavaScript, which would run after. And so as developers, we had this really complex world to manage where we've got server-executed code, you've got client-side executed code, and sometimes your client-side executed code can be dynamic. I don't know if anyone else here, but I have written server-side code that writes dynamic JavaScript. It feels weird. It's really hard to reason about. And then we've gone even further now. Even our CSS, even the styles that tell us what color our application should be, can now be compiled as part of our development workflow. We also used to cache things as web developers. So I don't know about anyone here, but I've spent significant time looking up and then forgetting and then looking it up again, how to do e-tags and how to do last modified in order so that my user doesn't have to request the same files multiple times. So we've all developed this as a discipline as web developers, but things have changed a little bit. Now we write applications that cache themselves. By using Service Worker and building progressive web applications, instead of relying on these kind of tried and true HTTP header caching control policies, we now can take complete control of that process using something like a Service Worker that is going to intercept every HTTP request our application makes and allows us to choose on the fly how we want to respond to those requests. We used to have this thing called applications, right? We would write a desktop application, we would give our user an installer, and it would be installed onto their system. But then we shifted into the web dev mentality where we wanted to ship individual pages. So we had an individual state of the application at a point in time. But now we're shifting almost all the way back to building applications again, where it's easier for us as developers to reason about a single experience as a cohesive unit. And web technologies are enabling that in ways that weren't possible 10 years ago. My JavaScript environment, that thing that I used to just output via ASP, and I used to just stuff it in my HTML, that now has a config file. This, on the left, we've got a generation from the Angular CLI of a bunch of different configuration files that try and automate and extract some of these for you. But there are a bunch of configuration files, right? There's what do you want your editor to be completing for you? What do you want Git to be ignoring? How do you want to do your unit testing? How do you want to do your end-to-end testing? And then we have a configuration file called a tsconfig for our Typescript so that we know how we want to do our JavaScript compilation process, and we can control how that works and how strict the compiler should be. This is a really crazy world that we're kind of living in. And as I said, it feels like we're reinventing the wheel and we're rediscovering things that we had been doing for a long time. Why do we put up with this? Why do we want to live in this kind of new world? And I would posit that it's all about user experience. It's all about our users. Our users are in a wide variety of places across the world, right? We're on planes. Brad was composing his slides on the plane or maybe touching them up a little bit. We're on trains. A lot of us even are on desktops. But in all of these places, we can now build better experiences than we could when you wanted to build a traditional server-side application. Because when you build an application and you make your users wait, you make them wait for a full round trip to the server every time they want to interact with your app, every time they want to make a purchase, that kills your chances of success. And I won't go into the numbers because I think we've all seen these a lot before, where every second of interaction time that you trigger for a user, every time they have to wait for you, it reduces the perceived quality of your application, it reduces engagement, and it reduces conversions, however you define conversions. And I talk to a lot of companies on the consumer-facing side where conversions are very easy to measure, right? It's did they buy? How much did they buy? Were they successful in that workflow? But there's a lot of enterprise conversions that some of us underestimate. Are my users being effective at their jobs? Do they feel happy? Do they feel in control of the systems that they have to work with every day? We've all used systems that have been mandated by companies that kind of suck. And we are less effective at our jobs when they suck. And so focusing on these user experiences is really, really important no matter what the context. So I want to follow this trajectory. So we want to kill the waiting time that we're creating for users, right? And so I have a traditional server-side rendered application. And step one, I want to kill that round-trip latency. So every time I click, I don't want the user to necessarily have to reload everything from the application. So we're going to add a bit of asynchronous content to our app. So maybe, for example, when I click the filter button, it's going to filter my list and just make a single AJAX request, a single asynchronous request to the backend, which then will pull from the from the API. Then we started running this async request, but we want to load more, right? Now we're having to render and manage the DOM in multiple places. And as we move more and more of our application code into this world where we're making tweaks to the DOM kind of one by one, it really does become a bit of a nightmare to manage. Because managing those things at runtime is hard. You have intersections between these modifications that you're making that are rather unpredictable if you're doing them one by one. And so you really have to find a different solution, a different way of doing this. And so when you get to that point of building these highly user experience-focused applications, you need a platform like Angular. Because Angular was really designed to make it easy to manage all these interactions and make it easy to express the things that you want your application to do in a way that then is going to render and operate on these underlying primitives that are coming from the web platform. So I'm going to give you a few of my assumptions and shortcuts that really I hope will be at least beneficial to some of you in the room. And if you disagree, tweet storms are accepted. TypeScript. TypeScript is going to make your lives easier. Some developers ask me about why they should use TypeScript with Angular. And in general, I say you actually don't have to use a lot of TypeScript to use Angular. We use TypeScript necessarily in basically two places. We use it for our dependency injection. So whenever I want to get access to a service that's being provided from the injector, I'm going to use its type to refer to it. And then in any of my decorators, that's a syntax that we're relying on from the TypeScript compiler. Beyond that, you don't actually have to write much TypeScript. Almost all of the valid ES 2015, ES 2017 JavaScript that you're writing is going to be valid TypeScript automatically. But what I would say is definitely consider using TypeScript because it's going to make all of your code better. It's going to make it better just by the fact that you get type inference, even if you're still writing JavaScript. But if you want to operate like a large company, and we see this extensively within Google, as a company, we've set standards for how we write TypeScript. So we've turned on all of the advanced options, so strict null checks, right? Not allowing developers to do things unintentionally really ensures that you have a code base that's going to scale. And so when we're building applications, even if you're just a team of one, I like to say that there's no such thing as a team of one. Because after 6 months of developing, you've basically forgot what you did 6 months ago, and now you're a second developer. You're looking at this person's code, and you're like, what was this person thinking? This person was an idiot, right? So now you're a team of 2, and then 6 months later, you'll be a team of 3. And so teams grow very, very organically. And having something like TypeScript can help you express that intent in code in a way that's going to make sense to you 6 months or a year later. Compilation really is the future. I mean, it's also our past, but I think that there's broad kind of consensus across the ecosystem that more of the work that we do as developers should be happening at build time, because the sooner you can find these problems in our code and the problems in our applications, the more effective they're going to be and the cheaper they're going to be to fix. And so using something like the Angular compiler lets you write applications the way you like to, and then let the platform really handle all of the translations that are going to turn that into primitives that are going to run either on web or on mobile or in whatever sort of manifestation your user experience is going to have. I'm going to be a bit opinionated for a second. If you haven't chosen a CSS framework, either go with pure CSS and be happy about it, or just choose Sass. It's probably one of the most prevalent CSS compilation frameworks. And again, one of my favorite attributes is that all CSS is also valid Sass. So by choosing to start out of the box with a large-scale project, you're ensuring that your team can be set up for success in the long term, but you don't have to kind of adopt all of the capabilities and all of the advanced functionality day one. One of the most common questions that we get on the Angular team is, how should I be managing my state and my data that flows through my application? NGRX is rapidly emerging as the kind of go-to way of managing data. So there's NGRX store, which follows the Redux pattern, so to say. So it gives you a one-way immutable data flow through your application that in many cases makes it easier to reason about what's happening in a given point in your application's execution. But it also gives you a single understanding of what is the state of my application. And there's some awesome dev tools that will do things like time travel, so you can step back through all of the actions that have happened in your application and see what effect that had on the UX and what side effects that may have had in your backend. Lock your dependencies. So this is something that large-scale teams have figured out. You cannot necessarily, or at least you didn't used to be able to rely on NPM for dependency management. It's gotten a lot better with NPM 5. But you need to both lock your dependencies, but also the dependencies of your dependencies. Some of the biggest breakages and failures that we've had over the past year with Angular and the Angular CLI is when we weren't in control of someone's child dependencies, or we weren't in control of one of our child dependencies. And so having a system that makes sure that you don't have your environment getting out of sync with what you expect is extremely important. So with npm v5, we have the package lock file, but I also have seen Yarn. None of these tools are perfect, but I've seen personally more success with Yarn recently. This is an area that I see a lot of innovation going on in, and I hope that all of these tools are going to continue to progress. But make sure that you're locking not just your dependencies, but your dependencies of your dependencies. Another thing that I talked about a little bit earlier in the year at Google I/O was this idea of how can custom elements work well with a platform or framework like Angular. And the answer is that they work really, really well. When we end up at enterprise scale, when you have companies with thousands and thousands of developers, you can't always make a singular technology choice for the entire company. And so being able to say, hey, we're going to build a subset of our code as an interoperable piece, and then we're going to build the application layer, the orchestration layer as Angular, and then pull in these lower level pieces, that can be a very effective thing. And this is something that the Angular team is spending a lot of time looking at. How can we make sure that Angular is as interoperable as possible so that you have great developer experiences, even at large scale in companies where you don't have control? Lastly, I want to talk a little bit about how the Angular team is trying to push us all forward as an ecosystem, as a world of JavaScript developers now. My first thought is really use the CLI. At this point, about 80 or 90% of the companies, even the largest companies, are using the CLI because of the ways that it solves problems or allows the developers to not have to think about problems that come with this modern web ecosystem. So if you use the Angular CLI, we're going to polyfill for you. And we even have a polyfill.ts file that has it broken down in terms of which browsers you want to support and then how you can support them by adding additional polyfills. We set up a generic TypeScript configuration file for you. So maybe you don't want to learn all of the crazy cool options that TypeScript gives you. You don't have to do that day one. We're going to handle all of the bundling and building. And this is we could talk for hours about how complex bundling and building JavaScript is. And I think, Alex, you have 2 hours about that today. But this is a very complex process that the CLI is trying to make easier. test your code. So at Google, basically all of the code is really, really, really well tested. And so this is something that we've seen as being critical to our success at building applications at scale, and we want to make other developers successful at testing. I know we've all thought, hey, maybe it's easier just not to test. Like, I'll add tests later, right? We've all said that. But the CLI and some of our philosophies are that if we bake that in at the beginning and we make it really easy to get started using tools like Protractor for end-to-end tests, Karma for unit tests, and a really well thought through system of mocking for via the dependency injection system, we really hope that it's going to be easy enough for you to add tests at the beginning, even if it's just leaving the default tests that come from the CLI. Having a continuous integration test that makes sure your application builds, even if you never write another test, is still a really useful signal to you as an application developer or as a team about the health of your code base. Another thing that the Angular team is trying to really push forward on the web is this idea of lazy loading. So as more and more code moves into this JavaScript world and into the single-page application world, we have this problem where now my browser has to load a 11 meg application, that was the worst I've seen, all at once. And we don't want to inflict that on our users, again, because it always does come back to that user experience. And so Angular has made it very easy via our router to say this module should be lazy loaded. So look at what the URL the user has requested, and now let's go fetch all of the code necessary to render that path, to render that URL client side. And then that path will be still there on the user's device as they're navigating around your application. Another thing that we talk a lot about that we're really trying to push the frontiers on is server-side rendering. Because a lot of us think about the user experience, but there's actually users that are not human. Right? Computers often are some of the biggest consumers of the applications that we develop. And so thinking about the ways that they perceive experiences for your application is very important. And so by doing server-side rendering, not only can you make an application more friendly for computers that are crawling or scraping your application, but you can also increase decrease the perceived load time of your application. So it feels faster to your users, even when it isn't. Another really cool tool that Brad talked about coming out of Angular Labs is the idea of schematics. And so the CLI is built on and baked in a bunch of schematics that help you get started building your Angular applications. But the schematic system was designed with the enterprise in mind, focused on this idea that I can take these Angular schematics, the ones that they've given us, and I can throw them away and write my own, or we can take them and compose them. So I can take the Angular schematics, and then I can add in all of my copyrights, all of my standards that my team requires whenever we build an Angular application. Maybe we have a naming scheme that we need to enforce. You can do those sorts of things via schematics. It's a very, very powerful system that I highly recommend you take a look at. One of the last things that I want to really push on that the Angular team is a big fan of is this idea of JavaScript as multiple compilation units. What we have today in the CLI, which uses Webpack under the hood, is a single compilation unit. If I have 30 modules that are all independent, but they're all being used by the same application, I have to build them all at the same time. That means a single compilation pass to get everything out, which when you're building large-scale applications ends up becoming a problem, because if I need to build 30 or 100 different modules, that can take minutes instead of seconds, and that's far too long. And so we want to help the world build applications like Google does by breaking things down into smaller compilation units. One of the other projects that I'm excited about is what we call Community CI. And so this is an interesting project that we're not really sure where it's going to go yet, but we think it has a ton of potential. So within Google, all of the Angular applications are always up to date. And so we have a really good test base for whenever we make a change to Angular of whether or not that's going to work in more than 300 different applications at Google. And so that's fantastic test coverage, but other companies write applications differently than Google does. And so we're working with a few selected partners in order to extend our continuous integration system and our testing systems in order to get reporting back when we break other applications. And so if you're willing to think about this idea and talk about this idea and maybe send us issue reports in an automated CI way when the latest build commit to master breaks you, definitely come find me after the talk. I'd love to chat with you a little bit further. So to summarize, the web has changed fundamentally over the last 10 years. It's an exciting place where we can deliver far better experiences, but Angular is here to help. Thank you so much.